Imagine building a website with two other developers. One improves login, another changes the cart. The next morning, an older folder has overwritten the newest work. Now the team has Project Final 2, and Project Final Really Final. Nobody knows which copy is correct. This is the problem Git solves. Git gives a project reliable history. It lets you save checkpoints, compare versions, recover work, and combine changes made by different people. We will follow one team building an online shop and watch every command solve a real problem. By the end, you will understand commits, branches, push, pull, conflicts, and safe recovery. Git is a distributed version control system. That definition has three important parts. Version control means Git records how a project changes over time. Instead of keeping random backup folders, you create named checkpoints called commits. Each commit contains a snapshot of the project, information about the author and time, and a message explaining the purpose of the change. Distributed means a normal Git clone contains the project and its history. You do not need to ask a central server every time you inspect an old commit, create a branch, or save new work. Most Git operations happen on your computer and continue to work without a network connection. The third idea is collaboration. Developers can exchange commits and combine their histories. A shared server makes that convenient, but Git itself manages the versions. A useful mental model is a camera, a time machine, and a team journal. The camera saves a deliberate snapshot. The time machine lets you inspect or recover an earlier state. The journal explains what changed and why. Git connects those snapshots into a graph, so the history is not just a folder of copies. It is a structured story of the project. Developers need Git because software changes constantly. A feature that works today may break after tomorrow's update. A customer may ask when a behavior changed. A teammate may need to work on a different feature without waiting for you to finish. Git answers practical questions. What files changed? Which lines are different? Who made the change? Why was it made? Which version was deployed? Can we reverse a bad update without deleting the rest of the team's work? Branches also give developers safe space to experiment. A branch can hold a new design, a bug fix, or an unfinished feature while the main product remains stable. If the experiment succeeds, the team combines it with main. If it fails, the branch can be abandoned without damaging the stable line. Git also improves code review. Instead of telling a teammate, please inspect the whole project, you can show the exact commits and lines that changed. But Git is not a testing system, and it does not automatically make code correct. Good teams add automated tests, reviews, protected branches, and clear release rules. Git provides the history and the mechanisms. The team still decides how to use them responsibly. Git and GitHub are related, but they are not the same thing. Git is the version control software. It runs on your computer. You can initialize a repository, create commits, make branches, merge work, and inspect history completely offline. GitHub is a service that hosts Git repositories online. It adds useful collaboration features such as pull requests, issue tracking, permissions, and automated workflows. GitLab, Bitbucket, and private company servers can play the same remote hosting role. Think of Git as the system that writes and reads the project history. Think of GitHub as one place where a team can store and discuss a shared copy of that history. When you run git commit, the checkpoint is created locally. Nothing is automatically uploaded. When you run git push, Git sends commits to a remote repository. When you run git pull, Git receives remote changes and integrates them locally. Keeping this difference clear will make the rest of the commands much easier to understand. Our example project is Nova Shop, a small online store. Maya is the product owner. She wants customer login and a shopping cart ready for Friday's release. Alex is responsible for login. Sam is responsible for the cart. Both developers need to modify the same application during the same week. Without version control, they might exchange folders through chat, overwrite files, and manually search for differences. With Git, they can start from one shared history, create separate branches, commit focus changes, and bring the approved work together. We will follow the project from an empty directory to a team release. First, we create the repository. Then we save the initial website. Alex and Sam branch from the stable main line and work independently. They push their commits, pull each other's updates, review the features, resolve one conflict, and finally merge the release. This is the same basic workflow used in real projects. A large company may add more automation and rules, but the Git ideas remain the same. First, confirm Git is installed by running git-version. Next, configure the name and email that should appear in new commits. This is authorship information, not a GitHub login. Git records it inside the commit metadata. Now Alex creates a folder named Nova Shop, enters it, and runs git init-b main. Git creates a hidden repository database and names the first branch main. The visible project folder may still be empty, but Git is ready to record its history. Running git init does not upload the project. It only turns the current directory into a local Git repository. Alex then runs git status. This command reports the active branch, stage changes, unstaged changes, and untracked files. At this moment, there are no commits and no files to save. Git status is one of the best commands for beginners and experienced developers alike. Whenever you are unsure what Git expects next, stop and read git status before trying another command. Git work moves through a few distinct places. The working directory is the project you can see and edit. The staging area is a draft of the next commit. The local repository stores completed commits. A remote repository holds shared commits when the team pushes them. Alex creates index.html, styles.css, and app.js. Git status calls them untracked because no commit currently includes those files. Alex wants the first commit to contain only the page structure and styling, so he runs git add for index.html and styles.css. Those two files become staged. App.js remains untracked. This is an important point. Git add does not save a permanent checkpoint. It selects content for the next checkpoint. You can review the selection, change it, or unstage it before committing. For an existing tracked file, editing creates a modified version in the working directory. Git diff shows unstaged changes. After git add, git diff -- staged shows the version prepared for the next commit. Staging lets one messy working session become several clean commits. You decide which changes belong together instead of saving everything accidentally. Before creating the first commit, Alex runs git diff -- staged. The terminal shows the exact lines that will enter the snapshot. He confirms that the storefront heading and style sheet link belong together. Then he runs git commit -m, followed by the message, feat. Create storefront shell. Git creates a new commit with an ID such as A1B2C3D. A commit is more than a copy of changed files. It represents a complete project snapshot and points back to its parent commit. Git stores content efficiently, so you can think in snapshots without creating a full duplicate folder every time. The message should explain the result of the change. Update files is vague. Create storefront shell tells the team what the checkpoint adds. The main branch now points to this commit, and head identifies main as the active branch. When Alex creates another commit, main will move forward again. Git log --1 line displays a compact history. Git show can inspect one exact commit, including its message, metadata, and change content. This is how the repository becomes a searchable journal instead of a pile of mysterious versions. A branch is a movable label that points to a commit. It is not a complete copy of the project folder. When Alex creates feature/login from main, both branch labels initially point to the same commit. Nothing has diverged yet. After Alex commits login work, only feature/login moves forward. Main stays at the stable storefront snapshot. This lets Sam start feature/cart from main at the same time. Alex and Sam share the existing history, but their new commits can progress independently. The main branch normally represents the shared product line. Teams often protect it with reviews and tests. A feature branch represents one focused piece of work. It should have a clear name, a limited purpose, and usually a short lifetime. Branches are cheap because Git primarily creates another pointer into the commit graph. Switching branches changes which commit and branch head follows, and Git updates the working files to match. This is far safer than folders named Nova Shop login copy and Nova Shop cart copy. The relationship between every version is explicit, and Git knows where the histories share a common base. Alex runs git switch -c feature/login. The -c option creates the branch, and switch makes it active. Git branch shows an asterisk beside feature/login. Alex builds login.html and auth.js. He stages those files and commits, feat. add customer login form. Then he corrects the empty password behavior and creates a second commit. Fix, validate empty password. These are focused commits. The first adds a user capability. The second corrects one behavior. A reviewer can understand them separately, and the team could reverse the fix without removing the whole form. Main has not moved. If the login feature is incomplete, it does not affect the stable product line. Alex can compare the branch with main by running git diff main feature/login. The 3-dot form focuses on the work introduced since the branches shared a common ancestor. Git log main.feature/login lists commits that are reachable from the feature, but not from main. Before sharing anything, Alex can inspect, edit, test, and create more commits locally. That local freedom is a major benefit of Git's distributed design. Sam begins from the same stable main commit and creates feature/cart. His work changes cart.html and cart.js, while Alex's work changes the login files. Because they are on different branches, both developers can commit at their own pace. Sam saves, feat, adds shopping cart. Alex continues, improving authentication. Neither person has to wait for the other to finish. Git does not store two unrelated piles of project copies. Both branches reuse their common commits. Each branch adds only the snapshots and relationships needed for its unique work. If Sam switches from feature/cart back to main, Git updates the working directory to match main. When he switches to the cart branch again, the cart files return. The repository knows which snapshot belongs to each branch. Branches reduce accidental interference, but they do not eliminate communication. Alex and Sam should still agree on shared interfaces and pull updates regularly. If both developers change the same lines differently, Git may require a human decision during integration. We will resolve exactly that kind of conflict shortly. So far, Alex's login commits exist only in his local repository. To collaborate, the team creates an empty remote repository, and Alex connects it with git remote add origin, followed by the repository URL. Origin is simply a conventional nickname. Teams can use other names and connect more than one remote. Alex runs git push-u origin feature/login. Push sends the commits and required objects that the server does not already have. It then updates the remote feature/login branch. The -u option records an upstream relationship, so future pushes from this branch can usually use only git push. Push does not upload uncommitted edits. If auth.js has changes that were never committed, those changes stay in the working directory. Push shares commits and reference updates, not random, unsaved files. After the push, teammates can see Alex's branch, and the team can open a pull request for review. The local branch, the local remote tracking name origin/feature/login, and the branch on the remote are related pointers, but they are not the same object. Committing saves locally. Pushing shares. Keeping those actions separate gives developers control over when work becomes visible to the team. While Alex was working, Sam's cart feature was reviewed and merged into remote main. Alex's local main is now behind the shared repository. Git fetch origin downloads remote commits and updates remote tracking references, such as origin/main. It does not move Alex's editable main branch, and it does not replace his working files. This makes fetch a safe way to inspect what changed before integrating anything. Alex can run git log main origin/main to see commits that arrived on the remote. He finds Sam's cart commit. Git pull combines two steps. Fetch, then integrate the fetched history into the current branch. Depending on the team's configuration, integration may use merge or rebase. Alex switches to main and runs git pull -- fast forward only origin main. Because Alex has no unique local commits on main, Git can fast forward the branch directly to Sam's newer commit. The history remains a straight line. The fast forward only option is useful for a stable main workflow because it stops if local and remote histories have diverged. Instead of making an unexpected merge automatically, it asks the developer to inspect the situation and choose intentionally. Alex now updates the login branch, runs the tests, pushes the latest commits, and opens a pull request. A pull request is a collaboration feature provided by the hosting service, not a core Git command. It gives Alex a place to describe the change. Sam reviews the code and checks the tests. Maya confirms that the user experience matches the release goal. Before integration, Main contains the cart, and the feature branch contains the login work. Both descend from shared history but contain unique commits. After approval, the team merges feature/login into main. A merge combines histories. In this demonstration, git merge -- no fast forward creates a merge commit, even if a fast forward might be possible. That commit records the moment the feature joined the product line. Other teams may prefer fast forward merges, squash merges, or rebasing before merge. The important rule is consistency with the repository's agreed workflow. Git log -- graph -- one line -- all makes the structure visible. The two lines of work join, and main now contains the storefront, shopping cart, and login feature without losing the history that produced them. A merge conflict does not mean Git is broken. It means Git found competing edits and cannot safely guess the intended result. Imagine Alex changes a button label to sign in, while Sam changes the same line to continue to match the cart journey. Both edits are valid in isolation. When Git tries to combine them, it pauses and places conflict markers in login.html. The section after head shows the current branch's version. The other section shows the incoming version. The developer must read the surrounding code and decide what the product should actually say. Perhaps Maya chooses continue to sign in. The developer edits the file into that final result and removes every conflict marker. Next, run the application and tests. Conflict resolution is a code decision, not only a text cleanup exercise. When the final file is correct, git add login.html marks it resolved. Git commit completes the merge. Git status shows which files remain unresolved throughout the process. If the merge began at the wrong time or the situation is unclear, git merge -- abort returns to the state before the merge when possible. Pausing, inspecting, and aborting safely is better than guessing through a conflict. Older Git tutorials use checkout for two different jobs. Git checkout main switches branches. Git checkout -- app.js restores file content. Because one command can mean very different things, modern Git provides clearer commands. Git switch is for branches. Use git switch main to move to main, or git switch -c feature/name to create and switch to a new branch. Git switch - returns to the previously active branch. Git restore is for file content and staging. Git restore app.js discards unstaged edits in that file, so use it only when you are certain those edits are not needed. Git restore -- staged auth.js removes the file from the staging area, but keeps the edited content in the working directory. Before switching branches, run git status. A clean working tree is easiest to reason about. Git may carry compatible edits between branches, but it stops when switching would overwrite work. At that point, commit the work, stash it, or deliberately discard it. Checkout remains valid and widely used. Switch and restore simply make your intention more obvious, which is especially helpful when the operation might discard changes. The correct undo command depends on where the mistake exists. If an unwanted edit is only in the working directory, git restore can return the file to its recorded version. If the edit is staged but should not be in the next commit, git restore -- staged removes it from staging while preserving the working copy. If a bad commit has already been shared, git revert is usually the team-safe choice. Suppose a launch discount was committed and pushed, but the calculation is wrong. Git revert, followed by that commit ID, creates a new commit that applies the opposite change. The original commit stays in history, and the correction appears after it. Teammates can pull normally because no shared commit IDs were erased. Git reset is different. It moves a branch pointer and can also change the staging area or working files depending on its mode. Reset is useful for carefully managed local history, but rewriting commits that teammates already use can create confusion or lost work. A simple rule is this: restore for uncommitted file state, unstage when the selection is wrong, and revert for a bad commit already shared with the team. Before any destructive undo, read git status and confirm exactly which changes you are willing to lose. Rebase is another way to integrate history. Suppose a private profile feature began from an older main commit. Main later receives new work, while the profile branch receives its own commits. The histories have diverged. A merge joins those histories and can create a merge commit. A rebase takes the feature-only changes and replays them on top of the newest main. The result can look like the feature started from the newer base. Rebase creates new commits with new IDs, even when the final file content is equivalent. That is why rebasing private feature work can be convenient. But rebasing a shared branch can disrupt teammates who still depend on the old commit IDs. To update a private feature, switch to it, fetch origin, and run git rebase origin/main. If a commit conflicts, git pauses. Resolve the file, stage it, and run git rebase -- continue. Git then replays the remaining commits. Git rebase -- abort returns to the pre-rebase state if the process is not producing the intended result. Merge preserves the original branch structure. Rebase rewrites the feature onto a new base. Neither is universally better. Use the strategy your team agrees on, and avoid rewriting shared history without coordination. Git stores data, but commit quality is about communication. A good commit has one logical purpose. It is small enough to review, has been tested, and has a message that explains the result. Fix stuff does not help a teammate understand the change. Prevent negative cart quantity names the behavior being corrected. The command is git commit, not git comment. The message attached to the commit is where you describe the change. Before committing, run git status and git diff -- staged. Confirm that no temporary files, secrets, or unrelated edits are included. Then write a short command-style message. A useful test is to complete this sentence. If applied, this commit will, if the answer is, add shopping cart quantity controls. That phrase can become the message. Some teams use prefixes such as feat, fix, docs, test, refactor, and sure. The exact format matters less than consistency and clarity. Good commits make reviews faster, reversion safer, and future debugging much easier. Here is a practical Git loop the Nova Shop team can repeat for each task. Start by switching to main and pulling the latest shared history with fast forward only. Create a clearly named feature branch. Build and test the change. Stage only the intended files. Review the stage diff and create focused commits. Push the feature branch and open a review. Automated checks run, teammates inspect the changes, and the product owner confirms the result. If main changes during review, update the feature using the team's chosen merge or rebase policy. After approval, merge the feature. Switch back to main and pull the completed integration. Confirm the branch is merged, delete the short-lived local branch, and prune stale remote tracking names. The commands are important, but the sequence matters more. Update, isolate, build, inspect, save, share, review, integrate, and clean up. Repository rules remain the authority. Some teams squash commits. Some preserve merge commits. Some rebase private branches. The safe workflow is the one the team documents and applies consistently, especially around protected branches and force pushes. The benefits of Git are now concrete. History makes every checkpoint inspectable. Safety means mistakes can be recovered without guessing which backup is correct. Branches let developers build separate features. Push and pull share local histories. Diffs focus code review. Commit messages preserve why a change happened. Exact commits identify releases. Git helps a solo developer experiment and recover. It helps a team review and combine independent contributions. In production, a deployed version can be traced to an exact commit. The remote coordinates the team, while each full clone also carries project history. That distributed structure gives local speed and offline capability. Most importantly, Git makes change visible and deliberate. The team can understand where the project came from and choose how it moves forward. Git is a distributed version control system that connects project snapshots into history. Edit your files. Use git add to prepare a snapshot and git commit to save it locally. Use branches to isolate work, push to share, pull to receive updates, and merge or rebase according to the team's workflow. Nova Shop showed the complete idea. Alex and Sam worked in parallel, reviewed exact changes, resolved a conflict, recovered safely, and combined their work into one release. Remember the mental model. Understand the state. Make one intentional change, save a clear checkpoint, and share it safely. Git makes change understandable, reviewable, and recoverable.